Hello, my name is Karen Dirksen. I am a PhD student here at the Virginia Tech Eastern Shore Agriculture Research and Extension Center, and today I want to talk a little bit about my research. My research deals specifically with soybeans and soybean soil fertility. Now, I want to talk to you about a nutrient that is becoming more and more popular, more and more concern for farmers, and that is sulfur. Now, back in the 80s, before the Clean Air Act, there was lots of free sulfate in the air due to industrial pollution, and so that got deposited in acid rain, and so farmers didn't have to apply sulfur. But now, as the Clean Air Act has come into effect, the air has become cleaner. That means less free sulfates in the air and less being deposited to our crops. And so farmers are beginning to question, how much sulfur do we need to apply? When is the most optimal time? Is there a specific source that works better than others? And that's the research I am doing here, and those are the questions that I want to answer. So in order to answer some of those questions, two studies were developed. One that studied the interaction between rate and source, and another that studied the interaction between rate and timing. The first study had 4 different rates: a zero control, 10, 20, and 30 pounds of sulfur per acre. And then at each of those 3 different rates of sulfur, I utilized 3 different sources: ammonium sulfate, gypsum, and elemental sulfur. And then also, because there is some nitrogen in ammonium sulfate, in order to determine the impact of that nitrogen, treatments of urea were applied at the rates equivalent to that supplied in ammonium sulfate. And then for the rate versus timing study, 3 different timings were utilized. All the fertilizer being applied at planting, all the fertilizer being supplied at R1 growth stage when the plant starts to flower, and then a split application where half was applied at planting and half at R1. And then over the course of last year, we did get some questions about ammonium thiosulfate. So in 2020, we did add that liquid fertilizer to determine the effects that that may have. During the season, to measure plant nutrient uptake, tissue samples were taken at the R1 and R4 growth stage. The uppermost fully developed trifoliate leaves without the petiole were taken and analyzed for total carbon, nitrogen, and sulfur content. And then additionally, at the R4 stage, whole plant samples were also taken and analyzed for total carbon, nitrogen, and sulfur content as well. In order to keep it simple, today I will just be focusing on the yield responses. With that being said, the timing test did not see any significant differences between the 3 different timings of applications. This chart displays the rate response when averaged over all 3 sources. Yield is on the y-axis and the different locations are on the x-axis. The Essex County area, Chesapeake area, the Eastern Shore AREC here in Painter, and the Tidewater AREC in Suffolk, Virginia. And you can see for each location, as we move from left to right, we increase from 0, 10, 20, and 30 pounds of sulfur per acre. At the first 3 locations, you'll notice there is no significant difference. But at the Tidewater location in Suffolk, we did see that the 10 and 30 pounds of nitrogen per acre rates yielded significantly higher than the control. This chart is the same idea, but instead, source is averaged over rates. So this shows the response of the different sources and the different effects they may have. Yield is again on the y-axis and location on the x-axis. As we move from left to right across each location, red bar indicates the zero control, blue is ammonium sulfate, yellow is elemental sulfur, green is gypsum, and the purple is the urea. And as you can see again, as we expect with the previous chart, there was no significant difference in the first 3 sites, but again at Tidewater we did see a significant difference where ammonium sulfate and elemental sulfur yielded higher than the zero control. This is interesting Ammonium sulfate we would expect because the sulfur is in a usable form. The sulfate is the type of sulfur that the soybean plant, or any plant for that matter, takes up in solution and is able to use readily. Elemental sulfur, on the other hand, needs to be broken down by microbes in order to be in that sulfate form that the plant can use. So in conclusion, timing was not significant. Higher rates of sulfur led to higher yields at the Tidewater location. Also at Tidewater, we noticed that ammonium sulfate and elemental sulfur led to higher yields when compared to the control. Both of these studies are being repeated in 2020. And in addition to them, we are also looking at the impact sulfur fertility may have on microbial interactions in the soil and how that all impacts nodulation. So with that, I would like to say thank you to the Virginia Soybean Board, Virginia Tech AREX, and Virginia farmers as well. Thanks for listening.